My name is Sander Hogevorst, student number 131646, and this is a pre-recorded presentation of my personal project, which was making a tool in Unity. This presentation will roughly be 15 minutes long. First, a sum up of what the goal of my personal project was, the game it's created for, and a short sped up video showing the tool in action. So the goal of this presentation. This presentation will focus less on the tool itself and more on the process and thoughts behind creating the tool. In this presentation I will go over 5 main topics. How the tool simplifies the game creation process for designers, a bit more of an in-depth look into the tool UI and the feedback the tool gives, some information of the more technical side of how the tool works, and lastly some of the problems I encountered and the solutions I found, as well as a look at if I managed to achieve the goals I set out for my personal project. I started this project to learn how to create a tool in Unity and to deepen my understanding of both C# and Unity. As I am a designer and everything I know about programming is self-taught, it does mean that my lingo might be a bit off sometimes. The tool is designed specifically for the game I created, and both the game and the tool are not fully finished yet. Through the tool, the user should have access to variables and settings needed to create levels and gameplay scenarios. It should be easier for the user to change and understand variables and settings and to create and alter levels. It is also important to note that the tool does not necessarily innovate on other editor tools, as this was not the goal of the project. The tool is made to create a top-down 2D action-adventure game for smartphones and is heavily inspired by 2D Zelda games. I shall now show you a short sped-up video of the tool in action as proof that the tool works. This video is 50 seconds long. Simplification was a big goal for the tool. This is because the tool needed to be accessible for users that aren't necessarily technical. Many scripts have a lot of public variables. An example here is an enemy NPC. These variables are needed to create new types of enemies with vastly different behaviors and variables. The tool instead will only show variables and settings relevant for placing them. This is in part to keep the variation of the same type of game objects within an acceptable range. So this is to make sure to ensure for the player that the same looking enemies don't all act differently. This is also to make sure for the user that they aren't overwhelmed with unnecessary settings and variables. Another part of simplification is that the tool does a lot of logic for the user. It also automatically builds a lot of logics, for example recover locations when the player falls in lava or linking two teleporters together. The tool can also create auto names for place objects, which makes finding and linking game objects easier. Each auto name always includes a unique ID, the type of object it is and the map it's placed in. An auto name can always be overwritten by a custom name. Game objects that are placed are also automatically placed within their map's hierarchy. Within the map's hierarchy, sub-hierarchies are automatically created for a game object if they do not already exist. Lastly, the tool makes sure that the user cannot select game objects that they should not select. This section will be about tool UI and tool feedback. One of the major problems was that the users did not understand the variables and settings they could alter, so I added tooltips. In the tool, every variable and button without text has a tooltip. If needed, I also added the tooltips at other locations that generally don't have tooltips, like headers and foldouts. In these places, an eye icon indicates that there is a tooltip available. Tooltips are written in plain English and are detailed and concise. Some tooltips also explain the current state of a variable, such as if there's an error in Y or why a variable is disabled. It will also always explain how to fix an error or how and where to enable the variable, as well as giving any other additional information needed. Colors are also used to inform the user. A red variable field means that the given value is incorrect, which generally means that it cannot be empty. And yellow means that the user generally has to do an additional action like pressing enter. Buttons are slightly different. Red buttons are destructive buttons. Pressing them deletes an element or a component. A yellow button means something is up, and pressing it will, for example, override a variable. A pop-up will always show up to ask if the user is sure. White buttons are normal one-time actions, and the bluish buttons are toggle buttons, where the darker blue buttons are set to true. Currently toggle buttons are not intuitive enough, and if I had more time I would have added a clear pressed visual to toggle buttons. If any variable or setting is incorrect, a clear debug will be printed on build or play. Debug prints will always point at the location where the error occurs and why. Debugs are also printed when the tool forces something, like not being allowed to select a game object, and selecting another object instead, as well as in some cases informing the user that an action is successfully executed. Pop-ups will always be given on major destructive actions, such as overriding a variable or deleting an element or component using buttons. The pop-up will ask if the user actually wants to perform the action. It will also inform the user if linked objects are or aren't affected. It is important to note that pop-ups are kept to a minimum and will never be displayed on build or on play. Foldouts are added to many parts of the tool. They are to make sure that the user does not have to unnecessarily scroll and to not clutter the tool with too much information. Through testing I found out that foldouts on their own weren't very clear. Thus I added indents to clearly show which parts were in which foldouts. The tool is split in two main tabs and an additional window. This is because the tool window became too cluttered and big. The Custom Inspector and Builder tab are in the main window and the Builder Details are in a separate window. In retrospect, the Custom Inspector and Builder Details should have been in the main window, as they are never active at the same time. The Builder could then have been in a separate window for easy access. After user feedback, I changed the tile visuals from a more standard array to clear rows, clearly showing the selected sprites and giving easy access to adding and removing elements. When using the builder to place prefabs or tiles, the builder indicator gives feedback of which map is selected, when multiple tiles are being placed and where, size of the object is being built, as well as showing when a build location is not valid to place an object at. When selecting an NPC, the tool will clearly show in what zone the NPC will patrol or the waypoints the NPC will follow and in which order if the order is not set to random. Additionally, the user can add wait times and look animations for when an NPC reaches a waypoint. In the Custom Inspector, the user can see how many waypoints the NPC has and which is selected, as well as easily selecting, deleting, inserting and reordering waypoints. Debug visuals are visuals the user can enable and disable in editor. This, however, makes the level quickly look quite cluttered. Therefore, I added a function that enables debug automatically when selecting a game object with a debug script. The user can still either individually or for all lock or unlock debug visuals. Further user testing with both a previous and a new tester showed that the tool was a lot easier to understand, and a level designer could pick up the tool with relative ease. General variables and settings are always shown in the Custom Inspector, but disabled if not applicable. This is to avoid having those types of variables pop up and giving the user information as to where to enable them. When scrolling within the window, the Inspector and Builder Select tab will always stay locked in place, and some buttons will automatically reorder their row size depending on the window size. Last up, many actions have shortcuts to execute them. I'm going to talk a bit more about how I set up the game scripts and the tool and the general rules I followed and why. The way I set up the game is to work heavily with script bases, which other scripts can inherit from. An example is the builder base. Any script that inherits from the builder base gets the build function, which the tool can call in its logic. This way, as the game evolves, a programmer can easily create more scripts and components that are supported by the tool. The Custom Inspector also works with script bases. It checks for supported bases on selected objects and will only show the relevant settings. In this example, the selected game object has a teleport, goal and tile visual script. Programmers can create new script inheriting from the bases, and the tool will, at least in part, be able to support the new script. I tried to make the tool as flexible as possible to support an evolving game project. As flags are strings with bools that the user can dynamically create. They are used by the game to save level states and can trigger the cutscene system. They are set in game by systems like the goal system, which the user can add to certain game objects. The tool is able to give an overview of all goals within a level and displays any errors. The game is currently able to save and load flags and their boolean states. However, the main issue currently is that all flags in the same level, as well as global flags, are never automatically checked for duplicates nor spelling errors. It was somewhat of a challenge to find information regarding creating a custom tool in Unity, and thus I had to be somewhat creative when problems arrived. In almost all of the cases I did figure out a solution to many of the problems. I will now go over a few of the problems I encountered and the solutions I made. At the start of the project I used a custom 2D navigation system which I created using a tutorial. But I didn't quite understand the system, therefore I chose to use a Unity navigation system instead. As Unity does not support 2D navigation, I had to convert all 2D logic to 3D. Under each style there is a 3D editor only plane to build navigation, and the camera automatically looks in the top-down view. A small part of the old navigation system still remains, in the form of a 2D array for each map which holds the tile information, which is used by the player and NPCs to check what tile they are on, without having the need for a lot of colliders. Navigation is automatically built through code while building the scene, but there is an issue when Purpose is enabled in Unity, which is that it can't always find a nav mesh, an issue that does not occur when Purpose is disabled. Building again will solve this issue. As a solution, the nav mesh is built twice through code, but the user still has to sometimes click away the pop-up. The tool places instances of prefabs when using the Builder tab. This means that the instances are also updated if the prefab is. There is a bug, however, with Unity's undo record function if an object is a prefab instance. Adding a new element to a list or array will save the size but not the element, which then becomes null on play. To solve this, the user can select to break the prefab for each individual builder button. This will make sure that the placed object is not an instance, which solves the bug, but it will no longer update when the prefab is updated. The builder details, which is in a separate window, always needs to be open if the builder tab is used. The tool will always auto-open the builder details if the main window is open. However, so far I'm unable to find a way to check if a window is minimalized, which makes it inactive and causes some problems when placing objects. At first, buttons in the builder tab were hard-coded. This was not particularly practical for an Evolve game project. Buttons would also have text instead of images, which made them hard to keep apart. So I created a system where the user could add new entities to tiles, NPCs and general prefabs. Each of the entities would become a button or a drop-down menu in a builder so it could be placed. Each entity has some general settings the user can change, as well as a category they are placed in. For buttons, the user can create their own custom categories and set names and tooltips for each individual button. A preview image is also auto-generated or can be set by the user. The last problem is that I have yet to find a way to override Unity input on a mouse click. As a result, left-clicking to place an object will still execute the Unity logics. To solve this, I put a frame over maps when the builder is active. The sprite's alpha within the border of the frame is 1. This way Unity will select it if clicking on it instead of ignoring it if the alpha was 0. The tool will always force select the frame and keep it in place. So when placing an object, the user can no longer accidentally select or move another game object. So in closure of this presentation, is this the best tool out there? Certainly not, and it's definitely not finished yet. However, when it comes to the goals I set up for the project, I think I did a very good job. And I'm quite proud of what I created. Especially as I'm a self-taught programmer and I knew nothing about making a tool in Unity. I find myself always using the tool when I work on the game, which for myself is an indicator that the tool streamlines the process a lot. Furthermore, I think it was a very good learning experience and I grew a lot as a developer. In the end, I think I achieved the goals I set out and even went beyond my own expectations. For one, the user only has access to variables and settings needed and they are easily changed. And I tried to make the tool as flexible as possible, as I knew it had to handle an evolving game project. Furthermore, I always used script bases as much as possible, which I could more easily integrate into the tool. And new scripts that inherit from these bases are at least in part always automatically supported by the tool. Also at the start I never planned to have the user add their own entities to the builder, but it made the tool a lot more flexible, as new prefabs could be added to the tool and old ones could be removed. Lastly, I focused a lot on giving the user clear feedback, color coding where needed, as well as having clear and concise debug prints and tooltips. Through user testing, I've seen that the feedback the tool gives helped a lot when it came to understanding and using the tool. And the tool does a lot automatically, making the process a lot more streamlined. So to sum up, did I learn how to create a tool in Unity? Yes, I definitely learned a lot. Does the tool work with the game I created? That it does. Is it easier to create levels and gameplay scenarios? It certainly is. The process is a lot more streamlined. And lastly, does the tool make it easier to understand variables and settings and make it easier for the user to change them? That it does. The user has access to all the variables they need and the tool gives a lot of feedback to the user. Additionally, the tool is a lot more flexible than I envisioned before I started. And through the learning process I was able to adapt the tool to suit a more evolving game project. This was my presentation on a custom editor tool I created. Thank you for watching.